In this video, I'm going to do number 2 about this, looking at the relationship between consumption of chocolate and the likelihood of suffering a stroke. Looks like they tracked these two groups of men in Sweden over the course of a decade, and then looked at the different rates of those that were suffering a stroke. So the first thing I'm going to do is I'm going to define my two parameters. Right? The reason I know it's going to be running a test is because the phrase, do the data provide convincing statistical evidence? Right? The moment I read that, I know they want me to run a test. So let's let P subscript A represent the proportion of men in Sweden who would fit in group A that suffered a stroke during these 10 years. And then because we have a two proportion z-test, I'm going to do the exact same thing, but instead of A, I'm going to change the A's to B's, right? So we have let P subscript B represent the proportion of men in Sweden who would fit in group B that suffered a stroke during these 10 years. Okay. After this, I'm going to set up my hypotheses. So my null hypothesis is that they are the same. So the proportion of group A minus the proportion of group B equals 0. And the alternative, right, this we're going to be careful. It's wanting to prove that the men who are classified in group A have a lower probability of stroke than those in group B. So if probability of A is actually going to be below probability of group B, when you subtract a smaller number minus a larger number, you get a negative number. So I'm going to put is less than 0. Okay, now I'm ready for my assumptions and conditions. So the first thing I do is one Swedish man having a stroke won't affect others. All right, then I'm going to look for randomness. Let's see. Randomly selected. Very good. So both groups were randomly selected. So that's good. And it's just convenient. It doesn't matter that they're the same, but it's convenient if I multiply 9,250 times 10. So 9,250 times 10, I get 92,500. And are there more than 92,500 men in Sweden? Yes, there are more than 92,500 men in Sweden, so our sample size is not too large. All right, so next up is the sample size assumption, which is 9,250 is a large enough sample. We've got successes and failures. We've got two different groups, right? We've got group A for successes and failures, so success and failure. And then group B, success and failure. So let's write down those numbers. Again, it's going to be weird to say it, but a success in this instance is a person suffering a stroke. So let's see. In group A, there were 458 cases. 458 cases of people who suffered a stroke, or men that suffered a stroke in group A. So if I subtract that from 9,250, I'll get my number of failures, 8,792. And then do the same thing for group B, which had 543 men have a stroke in group B. So subtract 9,250 minus 543, you get 8,707. Shouldn't be surprised here to see that both numbers, or all the numbers, are over 10. So all numbers greater than 10, so our sample size is large enough. So I'm going to write my statement now. The conditions have been satisfied. So I will use a normal model to run a two proportion z-test. All right, so let's do our sample size for A was 9,250. Our sample size for B was 9,250. Again, those don't have to be the same. Our number of successes for A was 458. Number of successes for B is 543. For the p-hats, right, you can go ahead and divide, or if you want, you can always run the test and fill this in later. All right, I'll go ahead and divide them in the calculator. But again, you don't have to. You can run the test with your stuff and then fill the stuff in after the fact. So I'm going to do 458 divided by 9,250, which gives us 0.050. And then for group B, it's 543 divided by 9,250. And that's going to be 0.059. All right, don't forget about the p-hat pooled here. We are doing a test of two proportions, so we do need to pool these together. Do 458 plus 543 over 9,250 plus 9,250. All right, so I'll go ahead and leave on. I'll hold off on that. No, I want to write my work, so let's just do it. So we've got 458 plus 543 divided by 9,250 plus 9,250. All right, so here's our pooled p-hat, which is 0.054. So that's what I'll be using in my denominator for my test to find my z-score. So z-score equals 0.050 minus 0.05. Was it 9? I already forgot. 0.59, yep. 59 minus 0 all over. So here's my pooled 0.054. If I subtract that from 1, I get 0.09. Let's see, 9. Oh, I'm sorry, not 0.09. Sorry about that. 0.946. That makes more sense. Over 9,250 plus 0.054 times 0.946 over 9,250. Again, these were the same for the sample sizes, but it doesn't always have to be like that. All right, here we go. Stat, let's run our test. This is a two proportion z-test, which is number 6. So I've got my first one, which is 458 out of 9,250. And then my second one is 543 out of 9,250. And I'm trying to prove that group A, or the first group, is less than group B. So that's the symbol that I had before. And hit calculate. And my z-score is negative 2.762. Negative 2.762. So when I shade, do my curve, it's pretty far over here. Shading to the left. All right, and my p-value is 0.003. So my p-value, which is right here, is 0.003, which is below pretty much any reasonable alpha that anyone would choose. I always use an alpha of 0.05. That's a pretty small p-value, so my p-value is below 0.05. So I will reject the null hypothesis in favor of the alternative. So essentially what I'm saying, if I go back to my hypotheses, is that we do have enough evidence to say that those men in Sweden who would classify into group A based on their chocolate consumption would have a lower rate of stroke than the men in Sweden who are classified in group B. So I'll write that out. There is enough evidence to say that the Swedish men who would fall into group A, right, based on chocolate consumption, will have a lower probability of suffering a stroke than Swedish men who fall into group B. And that is it. All right, so hopefully you had a chance to go through all of this. I know there's a lot going on. There's a lot to do, but this is what I expect you guys to be able to do for the test and for the AP exam in May. So if you have any questions, reach out to me, but this is what I'm expecting for a 2-proportion Z-test. Good luck.